All right, here are some questions off of the 3.6 homework that some students have had some questions about. And so before I start answering those, I do want to make sure that it's clear what it is we're looking for, right? So we talked about slope in this module, and you need to remember that slope is rise over run. So rise is how far up or down it's moving, and you're comparing that to how far left or right you're moving, right? So that's what we mean by this rise over run. And also it's important to keep in mind that slope and average rate of change are the same thing, right? So when it asks you to find the average rate of change, that's the same thing as slope. Right, because we're talking about linear equations. We're talking about these straight lines. And so that's what we're trying to find here when we're looking at this. So let's keep in mind the rise over the run. And so I'm going to write this down again, but I'm going to show the rise in blue, what I'm showing you on this picture, and the run in red. Well, actually, let's do it in green since that graph is in red. Okay, so rise over run. So when I'm looking at this, so the rise, right, so I'm trying to figure out how far it is from one point to another on this line. So if you look, there's places where we can see they meet. So you can see right here, all of these are different points on the line. And so I can use any of those points to be able to figure out my rise over my run. And so, but you've got to notice on this first one that the x-axis is moving by 20, right? Increments of 20, where on the y-axis, they're moving by 2s, right? Or at least that's how it's labeled. So we can see that halfway, in between this -6 and -5, or -4 would be -5. So if I was trying to list what this point was right here, I'd say, and then we can see that it is halfway between the 0 and 20, which would be 10. So over 10 down -5, right? So there's a point. And then we could pick any of these other points too. It doesn't matter which one we pick, right? So I can say this one here is 60, 0, right? So you're going over 60, up 0. And so those are just 2 points on the line, but of course there's a lot of different ones that I could see there, right? So if I was looking at the picture trying to figure out the rise over the run, right, then I'm saying that I'm going from the rise, I'm saying, okay, I'm going to go from -5 up, let's see, -5 up to this 0 here, right? So I'm just going to kind of draw a line like this, right? This is where I would meet up with that other one, right? So I'm going up from -5 to the 0, and then I need to move from 10 over to 60. Right, so there is my rise over my run. So if I was to write those down on there, right, so my rise, well, how far up am I going? Well, if I counted it out, 1, 2, 3, 4, 5, right, so I'm going up 5, so that's a +5. And then my run, I'm going to the right, and so that's also going to be positive. So I'm going 10, 20, 30, 40, 50. So I'll have 50 on the bottom. All right, and then I just have to reduce this fraction. So 5 can divide into both of those. Right, so 5 will divide into 5 once and into 50 10 times. So that means my slope is 1 over 10, which means it's going up 1 for every 10 to the right, right? So then I can kind of see that if I'm looking at it this way, right? So if I'm saying I'm going up 1 to the right 10, up 1 to the right 10, up 1 to the right 10, right? So it's my slope no matter what points I'm picking on there. Okay, so that's kind of how we're dealing with that one, right? So the slope is 1/10, the rate of change is 1/10, because remember, they mean exactly the same thing. And the only reason why they ask it in two different ways is to help you keep in your mind that the average rate of change is the same thing as slope. Okay, so now if we look at this other question, it's pretty similar, right? It's harder to do the counting on this one, though, when we're looking at it. And so we might have to use, the slope formula if that's going to be easier for you. So again, we'll say that the slope, right, it's the rise over the run. But also, we could use the slope formula too, if that's a little bit easier. And remember, that's the y2 minus y1 over x2 minus x1. So it's important with slope that you remember that it's always the y's that are on the top, because that's your up or down, right? That's what your y-axis is going up or down. And your run is always your x's, because those go left or right. Right? And so we could look at it either way and try and figure that out. So let's just go and look at 2 points that are maybe right next to each other. So if I went from here, the 7,000, right, and I was trying to find the rise over run from one point to the other. Well, my rise here is I'm going down, right, 1,000, because I'm going from 7,000 to 6,000. So that would mean that my rise is 1,000, and it needs to be negative because I'm going down. And then my run is going from, that looks like it's 150, right, to 200. And so 150 to 200 is going to be 50. So 50 needs to be on the bottom, right? And then I just need to simplify this, this fraction here, right? And maybe you can see, that 50 will divide into both of these, right? Maybe you're not sure how many times 50 will go into 1,000, but you can divide that into, use your calculator. So 50 goes into 50 once, so I have 1 on the bottom. And when I divide that out on the top, 50 goes into negative 100, negative 20 times. So that means that my slope on this is going to be negative 20. Or negative 20 over 1, but we don't have to put that 1 on the bottom. Oftentimes, when we're talking about slope, we do write it as a fraction, but, when you're writing it into your answer here, you don't need that 1 on the bottom, because anything divided by 1 is just itself. So our rate of change here would be negative 20. And again, make sure you remember, you understand why it's negative, because we're going down, right? And that's making it negative. We're going from 7,000 to 6,000. And then going to the right is going to make it positive. All right, let's look at the slope formula also, just because for some people that is a little bit more helpful to see it that way. So we're dealing with these points here. So this first one here is 150, right, comma 7,000. And then my second point is 200, and then up 6,000. Right, so those are my 2 points. And again, I can, write these as, the x1, y1, x2, y2, right? So my x's and my y's. All right, now these superscripts, right, these 1s and 2s, that just means this is the x and y coordinate of that first point. And this is the x and y coordinate of the second point. So that's why those 2s are there, right? Okay, so then if we follow this, right, so on the top we're going to have y2 minus y1, which is going to be 6,000 minus 7,000. And then that's going to be over, right, my x2, y2, so that's going to be my 200 minus 150. Okay, so again, when I look at this, well, 6,000 minus 7,000 is negative 1,000. And 200 minus 150 is positive 50. And so again, I get back to what I started with there, right? And that also reduces to be negative 20. All right, so both ways work, whether you want to think about it as the rise over run or think about it as the slope formula.